Hey guys, Shreyas here, and today we're in the first day of the August LeetCoding challenge, and the question for today is making a large island. So in this question, we are given an n cross n matrix of zeros and ones. So that's the binary matrix, and we can choose to perform one operation. So that one operation is changing 1 0 to 1, or we might prefer not to perform this operation at all as well. So after this, we have to find the largest size of the island in the grid. So that means the largest size of connected component of ones in the grid. So that's the question. It's quite straightforward. And for example, in this input, we have 1001. For this is the input that they are given. So initially, we have two islands over here. This is the first island, and this is the second island. So these two islands are not connected to each other because of zeros. So they are two separate islands, and now we can choose to perform that operation of changing 1 0 to 1. So we can either prefer to change this 0 to 1 or change this 0 to 1. In either case, the largest size of the connected component would be 3. So in any of the case, so the answer for this thing would be 3. And if the grid is already full of ones, then there's no point in, then we don't have any 0 to change, and the answer would be the size of the grid only, that is 4 over here. 2 into 2, that's 4. So that is the question, and the constraint is that n can be up to 500. So even an n cube or n to the power 4 solution might pass. So but there is an n square solution for this, which is the most optimal, which we'll discuss at the end of later part of the video. So before just going to the solution, like I'd like to recall a similar problem which is already very famously asked in most of the interviews, all those things. So that is finding the number of islands in a grid. So it's a similar problem where we have to find the number of islands instead of find the number of islands, that is find the number of connected component of ones. So in that problem, we used to use DFS and solve it, and we have to take ideas from that problem and apply to this problem to solve it as well. So we used to take we used to use DFS and mark all the visited nodes and find the number of connected components, right? And so in this problem, this is just a slight modification of that problem, where we can change at most 1 0 to 1, and then we have to find the size of connected component. So with reference to the previous problem that I was telling, instead of finding the number of connected components, we could also find the largest connected component. We can just track the largest island as we perform DFS in various cells of the grid. So that problem, we can use it for many purposes, and the same concept will apply to this problem as well. So the brute force solution for this problem would be, with each iteration, I change any 0 to a 1, and then I pass the updated grid to that function to find the largest size of the connected component. So, and after it returns me the answer, then again I change back the 1 to 0, and then I go to the next 0, change it to 1 again, pass it again. So for each 0 I keep doing this. For each 0 I keep calling the function of finding the largest size of the connected component. For each update, for each 0 I keep doing it, and at the end I will have the correct answer. But the time complexity is O of n square into n square, because to visit all the zeros it takes n square time, and for each 0 to find the largest, for each update of 0 to find the largest connected component, it will take another n square time. So the time complexity would be O of n power 4. While that might give us an AC for this problem, but there's an better solution for this problem. So let me explain it with the help of example first. So let's say this is the grid we have initially. So this is the grid we have, and now let's focus on this 1 0. So in the optimal approach, we have to analyze that by changing 1 0 to 1, how many islands would get affected, like how many islands would get merged, what will happen to the surrounding islands. So that's the thing we have to analyze in this optimal approach. So let's focus on this 0 1, and then initially let's just figure out how many islands are there in the original matrix. So in the original matrix we have 4 islands, right? So this is the one, and this is the second one, this is the third one, and this is the fourth one. So we have 4 separate islands in the original grid. Now by changing the 0 to 1, what happens? So if we change this 0 to 1, all these islands would get merged, because this is the common connecting point of all those things, right? From this point we can just go through all of the islands, so they all become a single island now. So this is how it becomes a single island. So 4 different islands got merged now. So there's the observation. So here instead of four islands, there could be only 3 islands or 2 islands, or only even a single island could have got merged with this updated one, right? So that's it. So the key observation is we have to find the number of islands which is surrounding a particular 0. So if we know the islands which are surrounding a particular 0 and sizes of those islands, then for each 0 we can easily update the answer. And to uniquely identify each island, we have to mark each of the islands with a different color or a different number or whatever, so that we can the sizes of the islands are clear to us while merging. So that's the only observation, that we have to uniquely identify all the islands, and more things will be clear with the code. So this is the main function of the problem. So the first part is just marking of the islands by a simple DFS function. So this is a DFS function I'm calling, and each time I call DFS function, I update the island number so that each island is uniquely identified with a different number. So I update the number, and then the DFS function returns me the size of that island, and I mark that island number to that size because later we will need it, right? And then update the current largest island in the grid. So DFS function is quite simple. I'm just going in all the 4 directions, up, down, right, left, and then I'm not visiting those nodes which are already visited, and just performing the DFS and returning the size of the island, current island. So that is the first function of marking all the islands. So now all the islands are marked. So now this is the second part of the function that we discussed earlier. So over here we'll focus on those cells which have 0 value, and for each cell which has a value of 0, we will just explode through all the 4 directions, up, down, right, left of that 0, and find out like which island is there to the left of it, or which island is there to the right of it. So that's why we are just going through all the 4 directions, and I'm just taking noting down the island numbers of those surrounding islands. So over here I'm inserting them in a set, because it might happen that in both the directions the same island might be there, and so there will be a repetition once again. So I'm using a set to avoid duplicates. And after I get all the islands surrounding a particular 0, I add up the size of the island. So because those islands will become merged, right? So I add up the sizes of those islands and then update the answer. So +1 is because the current 0 is changed to 1, and the sum is the sum of the sum of sizes of the surrounding islands +1. So they all get merged, and hence the updated answer, if sum +1 is greater than the answer gets updated. So we do that for all the zeros present in the grid, and then we just return the final answer. So over here you can see we reduce the time complexity from O of n power 4 to O of n squared. which is a great optimization. But the trade-off over here is the space, because we need to store the size of each of the islands. So so the space complexity over here is O of n cube, and again there's a space occupied by the recursion call, all those things. So the space complexity overall is O of n cube, and the time complexity as well is O of n cube. So yeah, that's it for the video, guys, and thanks a lot for watching. Have a nice day.